In last class we studied about orthogonal property of Bessel function. In this class we study about series solution of Legendre differential equation. The Legendre differential equation is 1 minus x square d square y by dx square minus 2x dy by dx plus n into n plus 1 y equal to 0. This is the Legendre differential equation. Take this as equation number 1. Then check coefficient of d square y by dx square is 1 minus x square. Coefficient of d square y by dx square is 1 minus x square. That is 1 minus x square. It is p naught of x. P naught of x d square y by dx square plus p naught of x p1 of x dy by dx plus n into n plus 1 y equal to 0. This is the standard form. P naught of x is the coefficient of d square y by dx square. It is not equal to 0 at x equal to 0. If you put x equal to 0 in this, then we get 1. It is not equal to 0. Therefore, we use power series method to solve this equation. First, assume the series solution of 1 in the form of y equal to summation from r equal to 0 to infinity ar x to the power r. Assume that this is the series solution of this equation number 1. Take this as equation number 2. Then differentiate this with respect to x, that is dy by dx equal to summation from r equal to 0 to infinity. ar is a constant. Ar differentiation of x to the power r is r into x to the power r minus 1. Then again differentiating this, we get d square y by dx square is equal to summation from r equal to 0 to infinity. Ar and r is constant. Differentiation of x to the power r minus 1 is r minus 1 x to the power r minus 2. Then substitute this in equation number 1. Then we get 1 minus x square. D square y by dx square is this. Put this. Minus 2x dy by dx is this. Plus n into n plus 1 y is this. This equal to 0. Then 1 minus x square. 1 minus x square. Opening this bracket means first multiply this to 1, again multiply this to minus x square. Multiplying this to equation 1, then we get same minus x square into x to the power r minus 2 means x to the power r minus 2 plus 2. Plus 2 minus 2 get cancelled, x to the power r. This equation x to the power r minus, because here is minus. Then minus, here is x to the power r minus 1 means x to the power r minus 1 plus 1. Plus 1 minus 1 get cancelled, it becomes r. Taking this side inside. Plus n into n plus 1 summation r equal to 0 to infinity ar x to the power r equal to 0. Then equate coefficient of various power of x to 0. First equate coefficient of lowest power. Here lowest power is x to the power minus 2. It obtained by putting r equal to 0. If you put r equal to 0, then we get x to the power 0, x to the power 0, x to the power 0. But here we get x to the power minus 2. It is the lowest. Therefore, first we take lowest coefficient, coefficient of lowest power of x. Coefficient of x to the power minus 2. X to the power minus 2 when r equal to 0. Means a naught, this is 0, 0 minus 1, x to the power minus 2. Coefficient of x to the power minus 2 is a naught into 0 into 0 minus 1, that is minus 1 equal to 0. Equate coefficient of x square to minus x to the power minus 2 to 0. That is, this is the coefficient, equating this to 0. Here already 0 is there, therefore a naught is not equal to 0. If a naught becomes 0, then 0 into 0, it becomes indeterminate form. Therefore, a naught is not equal to 0. Again, after this, the lowest coefficient is, lowest power is x to the power minus 1. It is obtained by putting r equal to 1. R equal to 1, it becomes x to the power minus 1. If you put r equal to 1, it becomes x to the power 1, x to the power n, x to the power 1. Therefore, we take only this. Coefficient of x to the power minus 1 is a1 into 1, 1 minus 1, 0. That is a1 into 1 into 0 equal to 0. Means here is already there, therefore a1 is also not equal to 0. Now we shall equate the coefficient of x to the power r to 0. Means we equate in general x to the power r to 0. Here x to the power r is obtained by putting r plus 2. If you put r equal to r plus 2 in this term only, in this summation only, if you put r equal to r plus 2, then we get r plus 2 minus 2. We get x to the power r. Here is already x to the power r, x to the power r, x to the power r. Only we have to put r equal to r plus 2 in this term only. Then coefficient of x to the power r is in this term a r plus 2, r plus 2, r plus 2 minus 1 means r plus 2. This is a r plus 2, r plus 2, r plus 1. Minus in this term minus a r into r minus 1. Here is already x to the power r is there. a r minus 1 minus 2ar into r plus n into n plus 1 ar. These terms 2ar r, x to the power r coefficient 2ar r. In this coefficient of x to the power r is n into n plus 1 ar. Equating these 4 to 0. Then taking these 3 this side, it becomes plus, and it becomes negative, minus. Then taking these two this side, it becomes in the it comes in denominator. Ar plus 2 is equal to, taking common as ar. In these 3 ar is there, therefore taking common as ar, the remaining terms are r into r minus 1 plus 2r minus n into n plus 1. Here minus is there. Taking common as ar, we get this. Again taking these two this side, it comes in denominator. Ar plus 2 is equal to, taking common minus, taking outside, minus n into n plus 1 minus r square minus r plus 2r is plus r. Taking common as minus outside, it becomes minus r divided by r plus 2, r plus 1 into ar. By putting r equal to 0, 1, 2, 3 and so on in this, take this as equation number 3. By putting r equal to 0, 1, 2, 3 so on in this equation, then we obtain a2. If you put r equal to 0, we get a2. In this also we put r equal to 0. If you put r equal to 1, then we get a3. If you put r equal to 2, we get a4, and continuing like this, we obtain these values a2, a3, a4, a5 and so on. We put these values a2, a4, a3, a4, a5 so on. We put these values in the expanded form of equation number 2. That is, we assume the series solution. We put these values in the equation number 4, expanded form of equation number 4, equation number 2. That is y equal to a0 plus a1x plus a2x square plus a3x cube and so on. See here, a2, a4 are in terms of a0. a3, a5 are in terms of a1. Therefore, even number terms are a2, a4, a6, a8 are in terms of a0, and a3, a5, a7 odd numbers terms are in terms of a1. Therefore, if rearranging these terms, a0, a2x square, a4x to the power 4 and so on, taking even numbers one side and odd numbers one side. Then substitute the values. a0 taking common as a0, because here is also a0, here is also a0, here is also a0, because a2 is in terms of a0, a4 is in terms of a0, taking common as a0 and substitute these values. Then taking common as a1, because x cube, a3, a5 are in terms of a1 only. Therefore, taking common as a1 and write this. Take this as equation number 4. Write this as u of x and this as v of x. Means u of x, this is v of x. That is, let u of x and v of x are respectively represents two infinite series in equation number 4, so that we have y equal to a0 of u of x and b and plus a1 v of x. This is the series solution of Legendre differential equation.